Good morning, all. For the subject data engineering, today's focus will be on the topics from Unit 2, which are highlighted here: examples and types of data architecture, technologies, till undercurrents and their impact on choosing technologies. So, this will be our target. And we are using this textbook of O'Reilly Fundamentals of Data Engineering by Joris and Matt Housley. This is the prescribed syllabus book, and we extracted contents of those topics from this book. So let us proceed further. The first topic is examples and types of data architectures. Okay, the first example is data warehouse, and data warehouse we already know is when we compare that with the DBMS, we know that the data is denormalized. You have starflake schemas, snowflake schemas. So data warehouse is huge as compared to database. And in databases, you use OLTP, online transaction processings, while in data warehouse, you use OLAP, online analytical processing. Okay, so this is the typical representation of a data warehouse. You have multiple data sources. You have an ETL system. ETL is extract, transform, load, and you have subsets of data warehouse called as data marts. The data warehouse. You can treat data warehouse as huge storage as compared to a database, and it is basically used for historical analytics, visualization, reporting purposes. As compared to ETL, you may have ELT also. So ELT is extract, load, and transform. So you have a staging area wherein all the data comes, and then the analysis and reports are extracted from the data warehouse. You also have a cloud data warehouse, and Amazon Redshift is example of a cloud data warehouse. You also have other technologies like Google BigQuery, Snowflake, which are separating compute from storage. So when you have separate compute and storage, data is housed in object storage. So object storage will be allowing what? Virtually limitless storage. Okay. So it will also allow us to increase or decrease computing power on demand. So next is a data lake. Uh, Data lake evolved with the question that why we should have tight structural limits on data. Why not simply dump all the data, whether it is structured and unstructured, into a central location? So what a data lake basically is it's a flexible storage layer for raw, semi-structured and unstructured data stored in object storage. Object storage formats, Parquet is one such famous format, and used on S3. And you know the long form of S3, simple storage services, right? So what data lake supports is exploratory analytics, data science, cost-effective retention. It requires strong metadata governance to avoid data swamp. Data Lake started with HDFS, and here for querying and transforming, it used MapReduce or Spark, Ray, Presto, Hive. You have data lake houses also, which will be combining a data lake and a data warehouse, uh, and it's a hybrid. So it will be combining the governance and transactional capabilities of data warehouse with the openness and scales of lakes. So it will be enabling both BI and ML workflows. BI stands for business intelligence, ML stands for machine learning. Uh, there's a lot of talk about Lambda architecture. So what happened is this is used for streaming. This is used for real-time analytics, And during that time, Kafka, Apache Storm, and Samza, they also evolved. So, and Lambda architecture, what it does is it will be separating the batch and streaming layers, and it will be providing low latency updates as well as historical views. Now, when they use with Kafka, Storm, or Samza, what companies could do was they could perform analytics and modeling on large amounts of data, user aggregation, ranking, product recommendation. But the challenge was the data engineer needed to figure out how to reconcile batch and streaming data into a single architecture. So that's when Lambda architecture came. And as you can see in the diagram, you have separate stream processing, serving, and batch processing. But Lambda architecture has its own challenges. It is error prone uh, because of multiple systems with different code bases you are trying to manage, right? So moving from Lambda disadvantages or challenges, Kappa evolved. So basically, Kappa came because Lambda has few disadvantages which Kappa tried to overcome. So what is the philosophy of Kappa architecture is it treats streaming as a primary abstraction. Processing all data as streams with a single processing path, simpler than Lambda in many cases. You can see here. So you have only stream processing, there is a serving layer, that's it. Then you have data meshes. They are more decentralized data storages. They treat data as products. They are suitable for bigger organization. So now coming to understanding the difference between immutable and transitory technologies, kind of they relate with today or for future. So when I speak about immutable technologies, I am speaking about technologies which will be used for long term. Okay. While when we speak about transitory, they are trend driven. Currently, this trend is going on. This technology is being used. So always immutable technologies become the foundational primitives over time. For example, you have S3 and blob, then you have computing basics, SQL, then Parquet or ORC formats. So what are transitory technologies? Some new framework comes, some new library comes, some new vendor product comes, and it has some short-term benefit, and we are not sure when it will vanish from the industry. So you need to balance both, right? And you need to encapsulate the transitory tools behind interfaces or layers. So what is preferable? Stable primitives from for long-term data persistence and design modular abstractions. So newer tools can be adopted without costly rights. Now coming to the location, location as in it determines where data systems execute. Are they are being executed on premise, are on the cloud, or are they hybrid, or are they multi-cloud? Suppose you are saying the data systems are executed on premise. So on premise means the organization has full control over hardware, networking, security. So usually these are suitable for legacy systems, strict compliances, predictable long-term fixed workloads. What are the drawbacks? More expenses, more maintenance, overhead, slower innovation. Now the location can be cloud, right? So, and we know the benefits of cloud because you have pay as you use model, operational simplicity is there, elastic scaling is there, it will be making faster time to market. But we need to watch for egress cost. So, uh, and we need to watch for vendor lock-ins, and we need to watch for cloud spend governance. What is egress cost basically? Egress cost is the fee charged by the cloud provider for transferring data out of their network to an external location. So what is a vendor lock-in? Vendor lock-in is a situation where a customer is dependent on a single vendor product. So it becomes difficult for him or costly for him to switch to other. Usually this dependency arises because of proprietary technologies, high switching costs, contractual obligations, complexity of migrating data or retraining stuff. Coming to hybrid clouds, what is a hybrid cloud? It's a mix of on-premise and on cloud. What is a multi-cloud? So bigger organization may be spreading across their data on multiple clouds, but it increases complexity, networking overhead, operational burdens. So what is the difference between monolith or modular? Monolith means single, tightly integrated systems. For example, legacy data warehouse, large ETL platforms. Modular architectures means you'll be using a lot of microservices, modern data stacks, which will be decomposing responsibilities into independently deployable components. So you'll be favoring modularity for long-lived evolving systems where teams and technologies will change. So when you are using modularity, invest in API, standard formats, robust orchestrations, clear SLAs. You also have serverless versus server-based systems. If you have dedicated servers, containers, they provide control, predictable performance, cost advantage at scale. If you have serverless platforms like fast, managed query engines, serverless warehouses, it does abstract infrastructure management. So the benefits are quick time to value, pay for use pricing, reduce operations. Uh, Coming to optimization, performance, and the benchmark forms. So, whenever we speak about optimization, we are speaking about balancing throughput, latency, and cost. When we speak about benchmarks, they are market driven. Okay, so sometimes the benchmark can be misleading also because they may be using synthetic workloads and they may not reflect the real production pattern. So what you need to do is you need to measure the representational workloads instead of using the synthetic test. You need to identify micro benchmark trade-offs. You need to be aware of, or rather beware of asymmetric optimizations. Uh, Basically, what you need to understand is you need to understand the gameplay of benchmark comparisons. You need to understand and monitor SLIs and SLOs. What are SLIs? Service level indicators. Say, for example, you have availability is one of the service level indicator, while SLOs are service level objectives. Maybe your availability you want 99%, that will be the objective, right? So coming to undercurrents, and undercurrents we always refer in the data engineering lifecycle diagram, and those undercurrents are mentioned as data management, data ops, security, orchestration, software engineering practice, FinOps. So when we speak about data management, strong governance, because if we have poor governance, data quality issues will be coming. When you speak about data ops and orchestrations, you have automation, you have CI/CD pipeline. So what is a CI/CD pipeline? CI indicates continuous integration. CD indicates continuous delivery deployment, and basically it combines those two practices, CI and CD. So what they will be doing is they will be automating the workflows, okay, in a continuous and reliable manner. What is a robust DAG? It's a workflow or data processing pipeline that is designed to be resilient, stable, and able to absorb uncertainty. So basically, it will be handling failures. Coming to security and compliances, you may be aware about GDPR and CCPA. GDPR, we all know, General Data Protection Regulation, takes care of privacy of individuals, their data. CCPA is California Consumer Privacy Act. Now, coming to software engineering practices, you need to reduce vendor lockings. We know vendor lockings, what is it now? You need to lower the TOCO also, and TOCO reverse total cost of ownership. Coming to FinOps, we know that we are combining finances and operations, and this will help balance performance versus cost. So this was a short discussion about the following topics called as examples and types of data structure till undercurrents in unit 2 for the subject data engineering. Thank you.